Welcome to a new video in my home automation series, and today I'm going to continue with the Influxdb related videos. And the next video I want to do is about tasks and how you can downsample data. And in order to get there, I need to talk about the Flux language and a little bit about Influxdb as well. I think I mentioned a few things. Sorry, when I say Influxdb, I meant Influxdb version 2.x. or 2.1 in my case. I mentioned some of these in the first video, but I think I'm just going to go through about the basics again. So you're going to see all the topics in this video. So if you're familiar with any of them, you probably can just skip that. So first, I want to talk a little bit about 1.x as well and 2.0 and how that is different. And also probably just here and there if you are completely new to Influxdb, but you have some experience with SQL, I try to just create some connection between the two. So what in SQL now represents in Influxdb and vice versa. So the first thing I want to talk about are the data section, and in that data section actually we are only going to talk about the buckets. So going back to SQL, you have databases, and within the databases you have tables, and within the tables you have fields. Those are your columns in the table, and obviously your data are the rows or the records. In Influxdb it has changed a little bit. We still have databases, but then in the databases you have measures. Sorry, I always say measures, but no, it's measurements. And those measurements, they don't have, columns, but they are either have tags and they have fields as well. I will highlight what's the difference between the two. So what has changed in, and one other really important thing in Influxdb 1.x is because it's a time series data, for everything, when we talk about data and databases, there is always a strong relationship to retention policies, which is basically how long the server keeps the information. So you said that you have a database and your retention policy is 1 week, which means that any data which is older than 1 week would automatically get deleted from the database. You don't have to do anything about it. And this being a time series database, everything has a timestamp. So basically anything that is older than 7 days, that just gets forgotten. Of course, you can create a database with unlimited, with a retention policy set to infinite, so it would just never expire. So it would work like any relational database. So in 1.x, the way your databases work is that the database would have a default retention policy, but you could define additional retention policies. So within the same database, you could store data that would expire after a week. You can also create data that would expire after a month or never expire. With 2.0, the naming convention has changed a little bit. So now instead of the databases, now we have things which are called the buckets, and this is what you can see now. And as you can see, under the bucket, you have a retention policy as well. So I have a couple of examples here. I mean, for the telegraph, so anything which is the system performance related data, I just set 7 days because I'm definitely not going to look at it after 7 days. And when you, sorry, not this button, but when you look at the settings for the bucket, as you can see, this is the retention policy. I mean, it just mentions delete data older than 7 days or never, but that's essentially the retention policy. And you don't see any other settings for the retention policy. So with 2.x, with Influxdb 2.x, the bucket and has a retention policy, and that's it. And that really determines how we are going to create buckets, because now, I mean, let's say previously when you created a database in Influx, you said maybe you create a database for a specific type of data, like system monitoring or environment sensors, or I don't know, maybe some system logging. But now when you create the buckets, you probably need to create buckets based on your planned retention policy. So for the same data, let's say you have sensor data, you're probably going to have several buckets. You would have a first bucket where you load the high frequency data. Let's say you have sensor data which is sending data every, I don't know, 10 seconds or 30 seconds. So you will keep that in a bucket, and then you would, from that bucket, you will downsample the data to, let's say, every 15 minutes or every hour. And those would have different retention policies, because you keep the high frequency data for, let's say, a month, and then you keep the less frequent data for a year. And maybe you can again downsample it to an even less granular level, and you can keep that forever, for example. So this is what, that's definitely one consideration for the bucket. So as you can see, and even if you create a new bucket, then you just give it a name, and then you specify the retention policy, and that's it. And once we go into the buckets, then within the buckets we have measurements, and the measurement is the same as your tables. So you have table information. For example, here I'm storing sensor information, data about all my sensors, and I also have this tiny GS. It's a small LoRa based ground station. I made a separate video on that. So any message about this ground station is collected in this tiny GS_message measurement. So again, back to the SQL world, these are your tables. And once you select your measurement, or within your measurement, you have fields, but those fields are now called tags and fields. In the relational database, you don't have, let's say, dedicated fields. You have fields that you usually specify whether that's an indexed field, because you want to run selection based on that field. So let's say, again, if it's a sensor information, you might have a field. For example, here you have a field which is called a device and a sensor. So for example, I have multiple devices, and then usually each device have multiple sensors. So I have a field for the device ID, and I have a field for the sensor ID as well. So my device could be a weather station, which have a sensor of temperature, humidity, and pressure. But in Influxdb, and that's same for Influx 1.x and 2.x, when you define fields, you have to think about that, whether these fields are going to be tags, and the tags are usually fields where you want to filter on. And typically tags are, or actually not typically, but tags are text fields. So for example, here I can see that if I select the filter device, I have I have some values like humidity, because I made some mistake when I was migrating my data, so it has some rubbish in it as well. But this is just a test database for the time being. But as you can see, I have devices, for example, a Me Flora, which is like a soil sensor for my plants, or I have a weather station. So if I select the weather station, then I can see that within this weather station, I have sensors, for example, humidity, infrared light, pressure, temperature, UV index. If I select the Me Flora soil sensor, then I have battery level, fertility, moisture, sunlight, and again temperature. Or I also have a device which is called the pool heater. So it has two temperature sensors. It's measuring the pool temperature and also like a solar heater temperature. So these are my sensors and the devices. And because I usually want to filter on these, so for example, I'm interested about the weather station data, and within the weather station, I'm interested about the temperature. This is why I've configured them as tags. So the way my data looks like is that I have a measurement sensor, and then within this measurement, I usually create data which has a device ID, for example, weather station. It has a sensor ID, for example, the temperature, and finally it has a field which is called a value, and that value contains the actual temperature reading. And at this point I realized that actually I don't need to create a separate tag as the sensor, but the actual sensor value could be the field name. So instead of having a field which is called a value, I could have a field which is the temperature, the UV index, pressure, light, infrared, whatever, and then that field contains the actual value. With Influxdb, it doesn't matter if you are sending just one data or you are sending all the data, because unlike normal SQL databases where you specify your table structure, so what are your headers, and then you're sending the data in for all the fields at once to create a record. Here you can create a record with, let's say, the measurement, with the tag weather station, and you can just send it a temperature, or you can send it a temperature and a pressure combination. So it gets stored. The database engine doesn't care about that. So I think what I'm going to do in the future is, instead of having this sensor tag, I just have multiple values for each of the different sensor type, or each of the different measurements. Again, I mentioned in the beginning is that the tags, they are always text types, but the fields are usually numeric fields. So it can be it can be any values like booleans or integers or float, and it can be text as well. But of course, if you have fields other than number fields, you won't be able to use functions, for example, mean, because it doesn't make a sense to create an average of a text. I mean, you can get the last and the maybe the first one, and maybe it will be possible to pick the most frequent one, but I'm not exactly sure. So your fields are usually value fields. And whenever you are selecting data, one of the important thing that you define, because it's a time series database, is you define what is the time window where you want to get this information. So if I need the last 15 minutes, I think these values are sent every minute? Yeah, so I get just 15 readings. If I want it for the last 2 days, obviously I get a lot more data. And when you are displaying data, the other key parameter which you can see here is what is called here the aggregate function, and that's going to come up in most of our queries as well, because let's say even in this case you want to display data for 2 days. I mean, probably with this data set where I have readings every minute. Well, if I have readings every minute, I think one day is 1,440 actual data points. And I mean, I don't have a 4K monitor to display all these readings. So even in this scale, some of my individual readings are going to be averaged. So what you can see here is that this Influx Explorer automatically selects an average or a window period for you, and within that window period the actual readings are going to get averaged. So here you can see that the window period is 10 minutes and the aggregate function is mean. So it's basically just going to show you data for a 10-minute interval. As you can see, if I start scrolling with the mouse, I can only see time increments of 10 minutes. And these values, the underscore value that you see on the screen, are actually averages of the individual values within that 10-minute window. And we are going to use that a lot because obviously if you want to look at a larger period, your aggregation window is always going to get bigger because, well, physically you can't just fit that much information on the screen. Okay, so I think with this I explained how let's say the data model looks like in a very high level, and by clicking around you already have seen how you can use the Data Explorer within the Influx UI. But what I want to show you is how you can see the data behind all this. So what I'm going to do now is I'm going to unselect all this information, and I'm going to pick a shorter time window as well. So let's say if I pick, so for example, if I pick 15 minutes, then you're going to see that the graph changes. And the graph changes because what Influxdb is doing is I only specify that I want to select data from the MyDB bucket, and I want to select anything which is a sensor measurement. So within that sensor measurement, we obviously have a lot of data. As you can see, I have a lot of information on the weather station, which has some details, and probably if I scroll over, I have some data from the pool heater, and maybe I can also catch the MeFlora sensor as well at some point. The MeFlora only sends data every 15 minutes, so I might not be able to get it in this 50-minute window. Technically, I should be able to, but it's here. No, it's not. It's going to be somewhere here. So, and this is why we are seeing so many different lines, because then Influxdb is going to give me any data or any field that matches this criteria. So it's going to be a lot of different values, and then everything is associated with a line in this graph. But what you can also do is you can switch to this raw data format, and you can see the individual values, or let's say the individual records. So you can see that the reason I picked 50 minutes because I wanted this aggregation window to be really small. So I get readings for every minute. So, and because the aggregation window is set to 10 seconds, nothing is really going to be aggregated here. So you see the raw value as it is stored in the database. And whenever Influx runs a selection or returns you a data stream, I think it's called a data stream, it has a specific fields. So it has a start and a stop, which corresponds to the start and the stop period that you selected here. And it also has a time. So this is the timestamp, which is coming from the data. And then it's going to show you all the tags. So I said I have a device tag and a sensor tag. And then it has the values. And then the values are actually displayed in two different fields. Sorry, it also shows the measurement, obviously. So it has two fields. The first is the actual field, what field the value is stored in, and the underscore value is the actual value. And as I said, for all my readings, I specified a device and a sensor, and the actual field is called the value. This is why the underscore field is called the value, and the underscore value is called the actual result. And if I start scrolling through, you can see that now we can see the pool heater, pool measurements, and at some point it changes to the solar, and I see the weather station humidity readings. So basically every single combination, you see the readings for this 15-minute window. So this is how you can check what is being selected. And I'm using this view a lot when I'm trying to fine-tune all my downsampling queries, and this is why it is important that we talk about here. And actually the other thing you can also do is you can switch to this table view, which is going to be very similar to the view that we have seen before. The only difference is that you also see this list here, because as I said, now I have only specified that I want to run the query on this bucket and this measurement, but this measurement has a lot of different tags and the combination of tags with the combination of fields. And each of these combinations are shown here. So as you can see, the field value, measurement sensor, and the pool heater and the pool heater and the solar and the weather station and the humidity. So you can see all these individual I think it's called the tables, and they all have the same start and the stop period, which is something which is specified here, the individual time for the measurement, the values, the fields, which is always going to be value, and the field name is always going to be value because this is how I created the data. But for example, if I go over to the TinyJS, it's going to be different, and the measurement and one of my tags and the other tag. Let me just actually show you something else in this TinyJS. And unfortunately, I mean, this has been migrated from my earlier database, and I've done the migration a couple of days ago, so I actually have to go back 30 days. So as you can see, for the TinyJS, the structure is different because I have filters, which is called the satellite and the station. So if I can select this station, and let's say if I select the satellite Norby, and I have a bunch of fields. So this is the, I have so many different fields here. In the previous measurement, I had only one field, which was called the value. And here I have fields, which is called elevation, distance, CRC error. So again, if I, let's say, back these, and if I only want to select on TinyJS, you can see the different keys. So I have the satellite FES and the station, this station, and you can see that these are the values that I get back. And if I select this, now I can see all my CRC error values and all the distance values and all the Doppler values. So it is basically creating a combination of your selection and like what is stored for that selection in the database. In this table view, you are seeing all the various keys, and whenever you select a key, you can see those corresponding records here. But if you just switch to the raw data view, then you see all these individual tables in one big list. So again, if I start scrolling through this, you can see that the I think the station, well, I only have one station, so the station is going to stay the same. For satellites, I usually receive data from 2 satellites, so that would change between FES and NORB, but you will see all the other fields being shown here. So within this 30-day period, I get 4 satellites data, or 4 satellite message. So we are going to have 4 alts, 4 CRC errors, 4 distances, 4 Dopplers, 4 elevations, frequency errors, and this is how I'm going to go through each of these values. Okay, let me go back to the sensors because I think it's a little bit easier to explain. And let me go back to 15 minutes. Okay, good. And actually now I'm going to switch to the script editor, because this is how we are going to learn how we can create a Flux query. And as I said, understanding the Flux query is important because you have to write a Flux query for tasks and the alerts as well. But I mean, technically, you can use the query builder to build your query, and you can just switch to the script view, and you can just copy and paste it. But I think to understand what happens here is actually it's going to be beneficial. So the other thing I wanted to say is that this Flux query is a database query language. So it is like the select in SQL. So the Flux language doesn't have anything to create data or delete data or modify data. And for that reason, if you want to delete anything from the database, you have to use the Influxdb CLI. So you still have a Influx command line in your command line interface, but previously, let's say in Influxdb 1.x, it would have like a text interface where you can create tables and databases and even data. Now you don't get any of this because now you have the UI. But still, for example, you can do some operations here related to the data, and one of them is where is it? It's called the delete. Where is delete? It's going to be here somewhere. So you can use this to delete information. And I have a couple of examples here. So for example, if you issue this one, which says influx delete, and then -- bucket, you specify the bucket you want to delete the data from, and then -- start, and you specify the start time and the stop time. So if I issue this command, then it's pretty much going to delete everything from my aggregates bucket, because all my data is between 2005 and 2022. So I'm not going to issue that because I just have too much data, which I'm going to use it for my next video. But if you want to further restrict what you want to delete from the database, you can also use something like this. So it starts the same way, influx delete, and then the -- bucket, and then start and stop. And then you have another parameter, which is the -- predicate. And here within single quotes, you can specify that the underscore measurement equals the name of your measurement. For example, I have the measurement sensors, and the name of the tag. For example, what was the tag? Device equals to something. So I can restrict the data deletion to, let's say, a certain measurement or certain tags within that measurement. And that again is going to become important because especially if you want to use aggregates, I think it's you are going to be doing a lot of trial and error. So you create some task, you let it run for a few days or at least one day. You look at how the data looks like in your bucket where you created the downsample data, and then if it doesn't work, you just delete it and start again. So and this is the reason all the Flux query starts with a from, because you define which bucket you're going to select data from. So it always starts with from and the bucket and my DB. And the next one is, again, because it's a time series database, whenever we want something related to a certain time frame, you also specify a range. And as you can see, the range has a start and a stop parameter, just like for the delete. And when in the Data Explorer view, you specify the information here. So obviously you can use this v.time range start and v.time range stop, which is going to get the timestamp from here, from this dropdown. But what we can also do, which we're probably going to do in a few cases, is you want to specify a fixed range, so which is not dependent on this dropdown. Again, especially for alerts and tasks, you're going to do that. So we are going to start minus 50 minutes. So that's the current time minus 50 minutes. And for stop, we are going to stop on the current time. And if I execute this, I get the exact same result back. So you can see that I have all the values from, so at the moment it's 2044, and then 15 minutes before was 2029. Sorry, 2044, yeah, and 2029. So the window is working, and if I change it to 30 minutes, then we can see that the start changes to 44 minus 30 minutes is 14. And as you can see, the way our Flux query is going to look like is we are going to start with a from every time, and every other statement is going to be after this pipe command or these pipe characters. So the way it sort of like works is that you select from this database, which is going to return everything that you have in the database, and then whatever the first line returns, you are going to filter down in the second line. And then we are going to filter it down further in subsequent lines. So I can put an extra pipe here, and instead of range, now we are going to use filter. And within the filter, we can filter on obviously measurements, tags, and values as well. So I'm going to just copy and paste my example here. So this is how it looks like when we measure on a particular measurement. So what you see here is I measure on the measurement sensors. So if I scroll all the way down here, we are seeing a lot of sensor measurement, but most probably at the end. Oh no, we don't have the TinyGS because we just don't have TinyGS data for the last 15 minutes. So if I execute this, you're not going to see any changes. We are still getting, no, actually we have downsampled some of the values. I think we have 52 pages before, and now we only have 26. And if you want to filter further down, you can add another pipe statement, and that's going to be another filter where the device equals the weather station. And if I do this now, I have fewer data because I don't have all the pool heaters and pool heater, yeah, he was pool heater device. So now I only have weather stations. And if I am only interested in the temperature data, which is coming from weather station, I can, add another filter, which is the temperature. So now you have the temperature information. And now we just have 3 pages of data. So this is actually looking good. And I can also filter on fields, but that's not going to make any difference here because, as I said, in this measurement, I have a single field, which is called the value. So I can, if I want to filter on any field, obviously the filter just have the field just have a name. So I say underscore field equals and the field name. And that's going to return just the same value. And whenever I do submit, the only thing you notice changing is the start and the stop time, which is obviously the timestamp whenever I press the button. Obviously the minus 15 minutes between start and stop. So this is how you basically run selection. So that's the, this is the select from statement. And this is a where clause where you usually filter on a time related field. And this is also one of your where clauses where you filter on like a field equals to sensors. And that's like another filter when your field equals to weather stations, the device equals weather station, and when the sensor field equals weather station. And whenever you are filtering on a single field, That's like in the SQL when you select, when you say select field name from. So you're not selecting all the fields like star, but you actually, specify a certain field, and this is what I'm doing here. So this is like select value from sensors, because technically the measurement is the table, where device equals weather station and sensor equals temperature, and time is, this time range. So this is how the Flux relates to SQL statement. And as I said, the other thing which we usually do is we create this aggregate window, and I'm just going to copy an example from what usually gets added to the gets added by the query builder. And this is what I talked about when I said that everything gets windowed to a certain period, just because usually not every time, but whenever you are trying to display a big enough range. And here we are using the function aggregate window, and it has a couple of parameters. I think we are going to talk about the every and the fn. So I'm not going to use these create empty at the moment. So here you specify what is your window period, and that again is stored in a v_window period, which is based on what you select here on the screen. I mean, you see that when you are using the query builder, you don't see it here. So I'm going to change this to something else. Let's say I'm going to change it to 1 day. And the function that we want to use, which is the mean. So that's the function that the system is going to use in order to aggregate the values within the window. And of course, you have a lot of different options here. I don't know how to pick all the different options, but if I just bring on the help, then most probably here in the function, we should be able to see, all the different selectors. So you can see we are using the mean. Where is the mean? It should be here somewhere. But actually we are going to use last and the max as well. So we are, we will see how that differs. Obviously, I guess you can get the idea now. So if I execute this, what you will notice, let me just do this one. So what you will notice that it's not an awful lot is getting changed. In fact, we are getting some extra values because I picked a window period which is actually smaller than my data resolution, because I'm getting data every single minute. So if I aggregate in every single minute, I just usually aggregate one single value. So nothing really changes. But let's see what happens if I want to aggregate every 5 minutes. Now I can see that I only have, I think I had 15 values before. Now I only have 4. The reason I have 4 and not 3, because this start and the stop period doesn't fall on precisely a equal 15-minute window. Probably there is a fractional minute in the beginning or at the end. And the way it works is that now you can see that we have these aggregated values. What you will notice that the start and the stop is still showing all the same for each of the lines, because that corresponds to the minus 15 minutes and the now. But the time now changes to these 5-minute periods. So your first 5 minutes is between the start time and this time, and then you have the various 5-minute windows here. And within those periods, the system has created the mean value of the readings. But let's say if I want to do 1 day, then obviously all these readings fall into a single day. So all I have done is just aggregated all the readings in this 15-minute window. So here 7.84 degrees is the average temperature for this 15-minute window. And if I want to display this, obviously now I can display it as a gauge. That obviously, expects a single value in the underscore value field, and now I can display that. And obviously if I change this one to max, then we're most probably going to see a slightly different value. Not an awful lot changes now in 15 minutes, but or if you want to see the last value that has come in, then you type last. Well, this appears to be the max as well. And we can quickly verify this. If I can comment out the aggregation window, so we can go back to the raw values, and I think probably this is going to be the last reading, yeah, and this is 7.96. And I wanted to explain you just by trying to come up with the equivalent SQL query, and obviously you would use this type of averaging if you use the group by function in SQL, but the group by function is really good for grouping by values, but it's not really used to group by time. And obviously this is where the time series database really shines, because one of the main measure and one of the dedicated measure is the actual, the time value which comes for each reading. So it is really easy to create a window and average it across time, because, well, you do have time for every single reading. And also, just to show you that if I comment out the field and also the sensor type, and if I execute, we will have a lot of averages as well. And you can see that now the system generates the average for us for the humidity sensor, the infrared sensor, the light, the pressure, the temperature, the UV and the UV index sensors. And still, because my aggregate window is far bigger than the actual selection range, now it's doing the averages for every single, I wouldn't say field, but every single tag combination. So I think this query would be equivalent to when you select mean value. So to select the mean of the value field from sensors where device equals weather station, weather station, and group by sensor. That would result a similar data structure returned if you are using a standard relational database. Of course, you will still have to put in some where clause for the time itself, but let's just ignore that for the time being. I think that should be enough for you to get started with Flux and Influxdb 2.0. Well, definitely, I think it's going to be enough just to understand what we are going to do when we done sample data in the next video, which hopefully is going to come in the next couple of days. I haven't created any documentation for this. I mean, literally, this is how much code, or let's say query, I have written manually here. And as I said, here I haven't used anything else that the system wouldn't generate you if you are using the query builder. And even though you probably don't have the same sensor database, this is why I said in the beginning of, or in my but in the second video, that you should install Telegraph and start collecting the data from your system, because that's going to generate a lot of information from you. And of course, the structure is going to be different, but you still find, for example, you can play around with the, I don't know, the measurement CPU or the disk and start building queries and trying to, build something manually and see how the data changes. And either using the row view or using the table view, you should be able to actually see how the queries and the filters work and how they return the data that you really want to see at the end. So I think that would be all for today. Thanks for watching, and hopefully see you in the next video.